Welcome to part 1 of 2 of a tutorial video series on how to use the BinMat R package. So this package was created to help the user process binary data that has been scored and binned from fragment analysis genetic methods such as ISSRs or AFLPs. And in addition to being available as an R package, it's also available as a graphical user interface via the R Shiny Apps platform. I will speak more about that a little bit later. But firstly, this package assumes that you already have your scored binary data. So you originally had electropherograms, which showed your peaks from your amplified PCR products, and you would have inputted that into a program like GeneMarker or RawGeno and scored and um, binned those peaks. And what you're now doing is you're just putting that output into BinMat, and you'll have your replicate pairs, and you can then consolidate them um, and then you can get error rates and summary information. And what I mean by consolidate is, let's say in this diagram you have rep 1 and rep 2, where there was a 0 and a 0, it outputs a 0 as a consolidated output. If there was a 1 and a 0, it would output a question mark as an ambiguity because there was a presence of a peak in rep 1 but not in rep 2. And then when both had a 1, it obviously outputs a 1. So there's a function in this package that just automatically consolidates every pair of samples in the data set. And then once you have that consolidated matrix, you then create a distance matrix using the Jacquard's index. And then that transformed distance matrix can then be used to create hierarchical clustering trees and non-metric multidimensional scaling plots, for example. So in part 1, I'll just talk you through reading in a data set of replicate pairs and then how you can consolidate that, you can get error rates, you can remove samples, and you can create a clustering tree. And then in part 2, I'll look at reading in data that has grouping information. So let's go right into R, and you just have to install BinMat first. It is on the CRAN repository, so you just go to install R packages and start typing it in here, and you just install it. I already have it installed, so I'll just select it. And so firstly, you want to read in some data. So I have an example data sheet here. Just note that I've deliberately put in a 2 there because I want to show you how it catches an error. This should just be zeros and ones. And you'll have a column of samples, sample names, and the first row is basically just locus positions. So reading this into R, I'll call it ISSR reps, and I'll use the read.csv function, and then I like to use file.choose, and then we just run this, and I'll just open the one. Here it is, and now it's in the R environment, so I can view it, and there it is. And now what you can do is you can use a function called check.data, and this just checks that the only characters present are zeros and ones. So that's why I deliberately put that 2 in to show you how it catches it. You pass it that object, and it will say there's an error. It's basically row 1, column 1. So if we go back, row 1, column 1. So let me just fix that. We'll make it 0. Save that. I'll just read it in again. And if I run this now, it will say none found. So it's just a nice way to just catch some possible errors before you've even read in your data. So what you can do next is use a function called peaks.original. And what this will give you is just an output of the average number of peaks in that data set. So let's run that, and it'll give you the average, standard deviation, the max, the min, and the total number of loci. So it's just a nice quick summary that you can do. And now, remember how I said you can consolidate replicate pairs. So you can use a function called consolidate. So I'm going to just create an object called cons, and I'm going to use the consolidate function and pass it this ISSR reps object. Once I've done that, let's view the consolidated data. So we originally had 8 samples. So obviously, if we consolidated it, we'd have half of it left. We'd have 4. So it combined A1 and A2, B1, B2, etc. And it's just giving you the consolidated output, which is really nice. It's just instant. You don't have to do a whole find and replace thing in Excel. So once you've done that, you can then, just as we got the summary information for peaks for the original data, you can now get that on the consolidated matrix. So you can you can run this peaks.consolidated, pass it in the cons object, and it'll give you the same thing, but this is now just on the consolidated matrix. What you can do then is you can look for error rates. So the function is just called errors, and you put in your consolidated object there, and it will output the Euclidean error, the standard deviation, and the Jaccard error and its standard deviation. So notice that the Jaccard error will always be greater than the Euclidean because it doesn't take the shared absence of a peak into account, so it's not biologically meaningful. But it's good to I think it's good to report both just to be safe. Let's say now you want to do some filtering. So maybe you want to remove samples that had peaks less than a certain amount. So I'll create an object called rem just for remove. And the function itself is called peak.remove. And you pass it in your object. So it's the cons. And then the second argument is a threshold. So what's the peak cutoff? So let's say it's 5. It's going to remove any samples that had less than 5 peaks, and it'll tell you which ones it removed. So you'll see here it removed 1, and this was sample C. So if I want to look at this object, it now has A, B, and D, and it's taken C away. So it's nice to just know that you can remove samples if you want. The next function, and the last one for this part of the video, is the UPGMA. So this is a clustering method. So just start typing in UPGMA, and you'll see that there are quite a few arguments that you can change. The default bootstrap value is 10, but it's good to usually set that to 1,000. But I'll leave it at 10 for now. You can also change the label size. There are different methods you can use, but you'll see binary refers to the Jaccard index, so just leave it like that. And you'll see from file is default the default value is false, leave it at that for now. Basically what that is, because this object has been consolidated within the package already, you just leave it as false. But in the next video, when you actually upload a new data set with grouping information, then you change from file to true because you haven't consolidated that right from the beginning. It'll be clearer later. So for now, I'll just pass in this consolidated matrix, and I'll leave it all the default settings, and you'll see here's your clustering dendrogram. Again, you can change the font size and everything you need. Let's say I want to make another one, but I want to only have the filtered one, so I want to have the one that had sample C removed. You can do that as well, just pass it in the other argument. This is the basic outline for the start. I'll make a second video on the grouping information and using a few more of the functions. So that's all for now. Stay tuned.